Hello and welcome to the C programming lecture on recursion. So what is recursion? Recursion is when something is defined in the terms of itself. So that statement in and of itself is pretty complicated. But really the idea of recursion is fairly intuitive once you understand what it does. We can just basically boil this down to say that like a function, using a function recursively, is when it calls itself. So in other words, like if we had a function that summed, we could call a sum function over several iterations to create a summation. So again, it's just when it calls itself. This is a weird concept, but it's powerful to help you solve problems. But every recursive problem can also incur some type of overhead, which we will kind of get into. So here is an example of a recursive function call. So we have a function named recursive power. We have two int parameters, x and e. And what we're doing is we can see in the definition, our implementation of recursive power, we have a check here to see if the exponent, the e variable, is equal to 0. And if it is, we return 1, right? So this is a simple example of how we can use a recursive function call. So if it's not 1, it will not return, or if it's not 0, it will not return 1. Instead, what it will do is it will return the result of x times another function call of recursive power, and we subtract e minus 1. So it's very important to have a basically kill switch for your recursive statements. Basically the return, the final return statement, right? Because this will keep calling after every iteration of the call stack. And you can picture it as just keep going down like a line until it needs to traverse back up that line. So we can see here that we call 2, 2. And what happens when we think about this, we say, okay, our first call is 2 and 2. So we say, okay, x is 2, e is 2. It skips over this if block because e is not equal to 0. It instead says 2 times the recursive power of 2 times 2 minus 1, which is 1, and it calls back into here, and now we're on a new call stack. And we do that again one more time, and then it just kind of keeps popping off nicely. So again, a recursive function call is when a function is defined in terms of itself. So breaking down this particular example again, kind of like I did in words, I wanted to provide you with a particular diagram that may help you kind of vision what's going on here. So breaking down the example again, we have our first call to a recursive power, assuming that we have 2 and 2. We say, okay, go ahead and say 2 and 2, but now we need to compute this last value here. We need to we recall our function that we're defining. So we're actually going to pass in 2 as our x value, and then 2 minus 1, which is 1. So we see here that our new call stack contains, our new stack frame contains the x here, 2, and then our int e, which is 1. And now what we do is we say, okay, from here we need to we actually go into another function call, and the x value does not change, it's still 2 in this particular case, and then our e is going to be 1 minus 1, which is 0, which is our exact return statement, our final case statement, basically. So what happens is it returns here at the very end. We can see in this purple node here, it returns the value 1. When it returns the value 1, we actually get in our next return statement in this call stack 2 times 1, which then returns the value 2, and we get to our final return statement, which then returns 2 times 2, which is 4. So we get back the result. And I hope this kind of paints a easy picture for you to conceptualize as to how a recursive function works. This is a very simple example. So a recursive stack overflow. Now, when a recursive function call is called repeatedly to the point where the stack has reached its hard memory limit, the program will crash. Now, this is often referred to as a stack overflow. Stack overflow can happen without a recursive function call. It could happen if you get so far deep into a function call stack that you just don't have any more space. And this typically happens in very complicated programs. I've only ever seen it really happen a few times using other various languages just because of how bloated they had become. So again, a brief review. A recursive function is when the definition of a function either directly or indirectly calls itself. Too deep of a call stack can result in a stack overflow, and recursive functions are a good example of a potential to have too deep of a call stack. So that's basically all I wanted to cover for recursion. We can go into a simple example of a sum in our code. Okay, let's go ahead and hop into our code example. So we're going to do our typical setup here. Create our file, open up our file, and make the hello world example. Make sure this compiles. And there we go. All right, cool. So the first thing we're going to do is define a function, and we're just going to go ahead and define a arbitrary problem to solve for. So what we're going to do is use summation. So what is summation? Summation is just basically taking a range of numbers and adding them all together. So we're going to keep a very simple example here, and I'll write it out in code. We're going to have we're going to pass the value 3, but we want this to occur. We want the value 1 plus 2 plus 3. We want this to be what we result in, which should be equal to 6. So we're going to do this recursively, and it should be fairly simple. So this is what we're going to do now. We're going to define a summation function. So here's our function prototype named summation. We're also going to do an implementation at the bottom. And what we're going to do is have our break statement here. And we're just going to use 0 as our return statement. So we're going to say, okay, return 0 in this particular case. And then else we're just going to do, we're going to call ourselves. You know, that's what makes this function recursive. So technically, what should occur here is we call this function. It will recall itself at the bottom with the x value decremented by 1, and it will eventually get to the end and give us a summation result. So in this particular case, let's just use the int s is equal to the summation of 3. So we're expecting the value of 6. So let's see. And that is exactly what we get. So, you know, there's multiple different ways that we can use recursion. There's actually different ways that we can do this without recursion as well, but sometimes it's easier to reason about a problem at first, maybe, you know, tackling it one way versus another. It's just another tool for you to try to use and help you understand how to solve a problem. It's not necessarily the most efficient way to work on a particular problem. So let's go ahead and just say that let's try to just pass in some crazy large number here. Now, you know, we could probably keep going larger and larger to potentially cause a segmentation fault, and there we go. So the segmentation fault again is just because we are creating just too much stack. We're basically having a stack overflow at this point. We have too much stuff on the stack. We just keep calling summation. So, you know, there's a particular limit that we're going to hit before we try to access some type of memory that just overflows into another segment. So I just wanted to show you that, you know, there is a limit to this stuff. Obviously, if you have a very deep call stack too, you can end up in this particular scenario as well. But especially when you're doing recursive functions, you saw how easy this was for me to kind of propagate. So it's a fairly quick and simple example, but definitely use this code, play around with it, think of other ideas that you can use. You can also do, you know, the multiplication version of summation, mess around with that, see if you can get the results that you expect out of it.